Float glass. The reason modern windows look perfectly clear didn't exist until recently. Before the 1950s, window glass was inconsistent. It had waves, distortions, and tiny imperfections that bent light in strange ways. Looking through it felt slightly off, even if you didn't notice it consciously. Everything changed when engineers discovered something simple. Molten glass could float, but not on water, on liquid tin. Tin melts at a lower temperature than glass, and, more importantly, it's denser. That means when molten glass is poured on top, it doesn't sink, it spreads out, perfectly flat. Gravity becomes the machine. As the glass slowly moves across the tin bath, the top surface is exposed to air while the bottom touches liquid metal. Both sides become smooth automatically, no polishing needed. Before this method, factories had to grind and polish glass manually, which was expensive and inconsistent. Float glass removed that entire step. Today, almost every window, mirror, and glass panel you see starts this way. Entire cities rely on a process that looks almost too simple to work. Tempered glass. This is glass designed to fail differently, because normal glass is dangerous. When standard glass breaks, it forms long, sharp shards that can easily cut through skin. Early car accidents made this problem obvious. Windshields would shatter and seriously injure passengers. So engineers didn't try to make glass unbreakable, they changed how it breaks. Tempered glass is heated to extreme temperatures, over 600 degrees Celsius, until it softens. Then it's cooled rapidly with blasts of cold air. But here's the trick. The outside cools faster than the inside. This creates compression on the surface and tension inside the core. The glass is basically holding stress within itself at all times. That stored energy is the key. When tempered glass finally breaks, it doesn't crack slowly. It releases all that energy instantly, shattering into thousands of small, blunt pieces. Still broken, but far less dangerous. That's why it's used in car-side windows, shower doors, and phone screens. It's not stronger because it can't break. It's safer because of how it does. Blown glass. This is how humans first learned to shape glass with precision. Long before machines existed, this was the only way to create complex forms like bottles, vases, and decorative pieces. The method is deceptively simple. A metal pipe, molten glass, and air. Glassmakers gather a glowing blob of molten glass at the end of a hollow pipe, then blow into it like inflating a balloon. But it's not just blowing. They rotate the pipe constantly to keep the shape even. Gravity is always trying to pull the glass down. At over 1,000 degrees Celsius, the material behaves somewhere between honey and lava. Too soft and it collapses. Too stiff and it won't expand. Timing is everything. Tools are used to stretch, cut, and shape the glass while it spins. Every movement has to be controlled in seconds. One mistake ruins the entire piece instantly. That's why even today, handmade blown glass is valued, because no two pieces are ever identical. Imperfection becomes the signature. Laminated glass. This is glass that refuses to fall apart, even when it's broken. Instead of a single sheet, laminated glass is built like a sandwich. 2 layers of glass with a thin plastic layer in between, usually something called PVB, a flexible but incredibly strong material. Under normal conditions, it looks just like regular glass, but the difference only appears when it breaks. Instead of shattering into pieces, the cracks spread like a spider web across the surface. The fragments stay stuck to the plastic layer. This wasn't invented for looks, it was invented for safety. Early car windshields used regular glass, and accidents often resulted in glass shards flying directly at passengers. Laminated glass solved that. Even when damaged, it stays in place, reducing injury. Today, it's used in car windshields, skyscrapers, and even security glass. Some versions are strong enough to resist bullets or explosions. It doesn't stop breaking, it just refuses to separate. Fused glass. This is where glass stops being industrial and becomes artistic. Instead of shaping one piece, multiple pieces of glass are combined into one. Different colors, textures, and layers are arranged carefully before heating. Then, everything goes into a kiln. At high temperatures, the glass begins to soften and melt together, but the final result depends entirely on temperature and timing. Lower heat keeps shapes more defined. Higher heat melts everything into smooth, flowing forms. Too much heat and the design disappears completely. Too little and nothing bonds. There's no undo button. Artists have to predict exactly how the glass will behave before it even melts. That's what makes it unpredictable. And that unpredictability is the point. Patterns form that can't be perfectly controlled or repeated. It's not just making glass, it's working with chaos. Cast glass. This is the heaviest and slowest way to make glass. Instead of shaping it quickly, molten glass is poured into a mold and left to cool over time, sometimes hours, sometimes days. The process seems simple, but the danger is hidden inside the cooling phase. Glass doesn't like cooling unevenly. If the outside cools faster than the inside, stress builds up, and that stress can crack the entire piece without warning. So the cooling has to be controlled extremely slowly in a process called annealing. Temperature drops gradually, sometimes just a few degrees per hour. This allows internal stress to release safely. The result is thick, solid glass objects that can't be made any other way. Sculptures, optical lenses, industrial components, anything that requires depth and strength. It's one of the most time-consuming methods, but also one of the most precise, because once it's poured, there's no going back.